Welcome to Prime and Composite. Now, what are prime numbers and what are composite numbers? Well, every number except for one has at least two factors. Factors are numbers that multiply together to give you a specific number. For example, the factors of 2 are 1 and 2. 1 times 2 is 2. These are factors. Now, like I said, every number except for one has at least two factors, 1 and themselves. So 3 has factors 1 and 3. 16 has 1 and 16. 8 has 1 and 8. Now the question is are those all the factors that a number has? And that's what makes the difference between prime and composite. Can you think, for the number 2, can you think of any other factors other than 1 and 2? Any other numbers other than 1 and 2 that multiply together to get 2? No, there aren't any. So that means 2 is prime. Let's look at 3. Can I multiply any numbers together, any whole numbers together, other than 1 times 3 to get 3? No. So 1 and 3 are the only factors of 3. That makes 3 prime. Now how about 8? Well, yes, there are other factors other than 1 times 8. I can also multiply 2 and 4. So the fact that 8 has more than 2 factors makes it composite. And if I look at 16, I think, well, 2 times 8 is equal to 16, and 4 times 4 is 16. So 16 has 1, 2, 4, 8, and 16 as factors. That means it has more than 2, so it is also composite. So what are our definitions? Okay, a prime number only has 2 factors. 1 and itself. Some examples of prime numbers would be 2, 3, 5, 7, 11, 13. Those aren't the only ones, but those are a good start. And 2 is very special because it is the only even number that is prime. Because any other even number is divisible by 2 makes them composite. A composite number, on the other hand, has more than 2 factors. More than 2. So that's at least 3. And in order to determine whether or not a number is composite, has more than 2 factors, you only have to find at least one factor other than 1 in itself. Some examples of composite numbers would be 4, 6, 8, 9, 15, 25. These numbers are important, 9, 15, and 25, because many times students get confused and associate odd numbers with prime numbers, and that's not always the case. 9, 15, and 25 are all odd numbers, but they are also composite because they have factors other than 1 and themselves. So how do I go about determining if a number is prime or composite? As the numbers get larger, this can be sometimes very difficult to tell. Now, it would be very easy if the number was even, because like I said before, The only even prime number is 2. So if you have another even number, you know automatically that that is composite. But in this case, we have 2 odd numbers. Are they prime or are they composite? We don't want to assume. So how do we figure it out? In another video, I talked about divisibility rules, which are very important here. Remember, to determine if a number is composite, all we have to do is find at least one factor other than 1 in itself, and if you do find that factor, that means it's composite. Take 57. Well, 57 is not even. It means it does not end in a 0, 2, 4, 6, or 8. So that means it's not divisible by 2. Okay, well, I'm not going to give up there. I know my rule for 3, determining if a number is divisible by 3, is adding the digits together. So I'm going to add 5 plus 7, and I get 12. Is 12 divisible by 3? Yes, because you get 4. So that means 57 is divisible by 3. That means 53 is a factor of 57. So 57 is composite. Now, if I use my rules for 61, of course, 61 is an odd number, so it's not divisible by 2. If I add 6 plus 1 together, I get 7. Okay, is 7 divisible by 3? No, not, at least not evenly. So 63 is not a factor of 61. And in fact, if I go through all my rules, 4, 5, 6, 7, 8, 9, and 10, I find that none of them work for 61. So that means that none of those numbers are factors of 61. So 61 is prime. And that may seem like a little bit of work, but it's the best way to determine for sure if a number is prime or composite.